Interpreting slope as a rate of change. In the examples we have seen so far, we have had the slope provided for us. However, we often need to calculate the slope given input and output values. Recall that given two values for the input, x1 and x2, and two corresponding values for the output, y1 and y2, which can be represented by a set of points x1, y1, and x2, y2, we can calculate the slope m. M is equal to the change in the output, which is the rise, divided by the change in the input, which is the run. So here we have the change in y over the change in x, which is equal to y2 minus y1 over x2 minus x1. Now note that in function notation, two corresponding values for the output y and y2 for the function f can be written as y1, which is equal to f of x1, and y2 is equal to f of x2. So we could equivalently write m is equal to f of x2 minus f of x1 over x2 minus x1. Now in figure 6, it indicates how the slope of the line between the points x1 and y1 and x2 and y2 is calculated. Recall that the slope measures steepness or slant. So the greater the absolute value of the slope, the steeper the line is. So here we can see what's happening with the slope of the line. Here you have your 2 points. This is the vertical distance, which is y2 minus y1, and this is the horizontal distance, which is x2 minus x1. Now, are the units for slope always the units for the output over the units for the input? And that answer is yes. Think of the units as the change of output value for each unit of change in input value. An example of slope could be miles per hour or dollars per day. Notice that the units appear as a ratio of units for the output per units for the input.